Hey class, what I'd like to do is I'd like to do a little short video to do a little bit of review for this test. So especially for those of you that are on Model C, please watch this video to review yourself over the concepts on the test today. There are going to be a couple questions that are going to be over translations, rotations, reflections, dilations, which is that transformational geometry stuff. It wasn't on the review, but I think you can still do okay. So just kind of listen to this little bit of review here, and that's about all you're going to really need. Remember, translations, when we're doing translations, what that really is sliding things to the right or left or sliding things up or down. Okay, so basically it is the only format that's going to have a plus and a minus in it. All the others will either have just a negative or they will have a times in it. Okay, so it's just sliding things from one side to the other. Reflections are flipping things over the axes. Okay, thank goodness that's all we have to do. So if you had a coordinate grid and I had a shape right here, okay, in quadrant 1, if I want to reflect this over the x-axis, that means I'm going to be flipping it over the x-axis down this direction. Okay, so if we reflect over the x-axis, our shape is really moving up and down the y-axis. So our y is going to change signs. Okay. If I have that same image, but this time I'm going to reflect it over the y-axis, that means it's going to move this direction, which means it's going to move up or across the x-axis. So my x is going to change. Okay, so that's what happens when we do a reflection. But the one thing I need you to remember with the reflection is that your x and your y don't trade places. They stay home. Okay, so the x stays in the x position, the y stays in the y position, and one of them is going to turn opposite. So just kind of remember that. A rotation, this in my opinion is one of the harder ones. Okay, now basically a rotation is if I have an object in quadrant 1, no matter where it's at, always think about the object in quadrant 1, and I want to rotate it either clockwise or counterclockwise. Remember, clockwise is to the right, counterclockwise is to the left. Okay, so if I were to take this object and rotate it clockwise, what I told you to remember is that your x and your y are going to rotate one turn. Okay, so they're going to trade places. And if it rotates over the x-axis, my x is what turns opposite. If it rotates over the y-axis, my y is going to turn. If it rotates 180 degrees, that means it's going to go 2 clicks and it's going to move down into quadrant 3 here. Okay, in quadrant 3, if it goes 2 clicks, the x and the y are going to rotate twice, which means it puts the x and the y back in the right spot, but both x and y are going to be opposite. Okay, so that's kind of how you remember that. A dilation is making things bigger or making things smaller. Okay, so it's the only operation or the only format that's going to have a multiply. But the one thing you got to remember, the number that we're multiplying by has to be the same number. Okay, so if I multiply by a number that is greater than 1, then my object gets bigger. Okay, if it is less than 1, then my object's going to get smaller. Okay, so kind of remember that. Okay, so those are the things with transformational. Okay, so let's look at a couple questions real fast. It says, look at the transformation. Which rule maps quadrilateral wxyz to quadrilateral w prime x prime y prime z prime? Okay, so we're taking this figure and turning it into this one. So that means it moved left and up. So I need a format that says I'm going to take the x and I'm going to move it left, and then the y and move it up. So that means it's going to be a minus for the x and a plus for the y. Okay, so now since we have 2 of those, we need to make sure that it is, am I moving 5 or am I moving 6? So what you do is you pick one point. So I'm going to pick this z right here, and we see how far did it actually move. Okay, so this one moved 1, 2, 3, 4, 5, 6 to the left. So that means it's going to be a minus 6. So that means the pluses are out for sure. And now that I know that it moved 6 to the left, I know J is out, so it has to be G. And so did it move 5 up? 1, 2, 3, 4, 5. Yes, it did. Okay, so the correct answer is G. Which representation of a transformation on a coordinate grid does not preserve congruency? Remember, there's only one transformation that doesn't preserve congruency, and that is a dilation. So if we were to come back and look at what a dilation looks like, a dilation means that I'm going to be multiplying. Okay, I'm going to be multiplying by some number, so that's what I'm looking for. Okay, so which one is dealing with multiply? A, it's the only one. And this one, since I'm multiplying by a value less than 1, my object is going to get smaller. The coordinates of the vertices of quadrilateral are PRST. Quadrilateral PRST is reflected across the y-axis to create quadrilateral P prime, R prime, S prime, T prime. Which rule describes this transformation? Okay, so no matter what this actually gives me, what I told you was always think about an object in quadrant 1, and I want to reflect this over the y-axis. So that means I'm going to be reflecting it this direction, okay, over the y-axis. So which one is it moving? It's moving along the x. So my x and my y stay home, but which one is going to turn opposite? The x. So we look down here to find that, and we find that it is B. We know that C and D are going to be rotations because my x and my y rotated. All right. Now let's talk about some of the definitions. Okay, so we'll just kind of go over these again. These are the same ones that were on our test, same ones that I gave you answers to the other day. Okay, so A, the angles that occupy the same relative position. Okay, that is going to be our corresponding angles. Two angles whose degree measures have a sum of 180 degrees. That is going to be our supplementary angles. Two angles that have sum of 90 degrees. That's going to be our complementary angles. A pair of non-adjacent, non-overlapping angles formed by two intersecting lines creating angles that are opposite and congruent. Opposite, what we're referring to are those two right there, and those are vertical angles. Angles that are inside of a triangle formed by two sides of a triangle. Angles that are inside a triangle are going to be interior angles. Angles inside parallel lines on opposite sides of a transversal. So what we're talking about are those two right there. Well, that's not one of the things that's listed over here, because these are what we call alternate interior angles. Okay, then G, angles that are outside of a triangle between one side of the triangle and the extension of the adjacent side. Well, outside is going to be exterior. Oops. I just hit the erase button there. So that is G for exterior. Angles outside parallel lines on opposite sides of a transversal. Okay, well, again, what we're looking for are those angles, and those we know are alternate exterior angles. Again, that's not one of the words that we have to look for. Okay, I, lines that lie in the same plane, that never intersect, and are always the same distance apart. Those are parallel lines. Lines that meet at a point for J, lines that meet at a point, those are intersecting lines. Lines that lie in the same plane and intersect to form right angles, that's going to be perpendicular lines. A line that intersects two or more lines, well, that is a transversal. And last one, a pair of non-overlapping angles that share a common vertex and a common ray, that's going to be adjacent angles. Now, some of the theorems that we need to remember. Remember, the sum of the measures of the interior angles of a triangle is 180. It's a triangle angle theorem. So if I take angle A, angle B, and angle C, that's always going to equal 180 degrees. So if we were to look at a question like this, we know with our calculator we would type in 47 plus 58 and get an answer to that, which I believe is, let's see, what is that? Let's see if I can add that. 8 and 7 gives me 15. Carry the 1, 105. Okay, and then we subtract that from 180. And you end up with 75. So this one is 75 degrees. And yes, you do need that degree symbol, so do not forget it. Okay, find the value of x. This one right here, we're going to use some algebra. So this one we know that We've got a 31, we've got a 90, and we've got a 3x minus 1. So that means I can do 31 plus 90 plus 3x minus 1 is going to equal 180 degrees. And then I solve it algebraically. So we've got, we take this side right here and we put together like things. So I change my subtraction. I put my 3x down plus, and then I take the 31 and the 90 and the 1, and I put those together, and I end up with 120 is equal to 180. So I subtract 120 from both sides, and I end up with 3x is equal to 60, divide by 3, and I end up with x is equal to 20. Okay, so x is 20. Now this one's not a degree measure, so I wouldn't need a degree symbol. Now we've got the exterior angle theorem. So we know that the exterior angle, which is outside the triangle, which is made by an extension plus a side length, is equal to the sum of the two remote interior angles, which are the ones opposite that exterior angle. So if you had a question like this and I asked you to find x, all we have to do is take this 21 and this 34 and add them together, and x is going to be equal to 55, and it would be degrees because it is an actual angle. Now sometimes you end up with some algebra with these. Okay, but we do know still that this 60 and this 2x, when I add them together, it's going to equal this 94. So we just write the equation. 2x plus 60 equals 94. We subtract 60 from both sides. We end up with 2x is equal to 34. Okay, you divide by 2, and you end up with x is equal to 17. So x is 17, and this one doesn't need a degree symbol because it's not an actual angle. Okay, and that's basically what this test is going to cover. Okay, so those are the kinds of things that you need to remember for this test. Okay, so the test is multiple choice. Okay, so you're going to take it on the computer. There is a section where you're going to find angles. So I'm going to give you some parallel lines like this, and I'm going to give you one of the angles, and you got to find the missing ones. Well, because of the way this form is, all you're going to do, if this one is 50 degrees, and I ask you to find angle 1, okay, angle 1 I know is going to be 130 degrees. Because of the form idea that we're doing, you're just going to give me 130. You're not going to give me a degree symbol or write out the word degrees. Okay, you know when you have to use it and when you don't. In this particular case, you're just going to give me the numeric value. Okay, and all the rest of them should be multiple choice where you're looking for A, B, C, or D, or F, G, H, or J. Okay, so I wish you the best of luck. Do the best you can. This will be the last grade of the 4th 6 weeks. So until next time, I'll talk to you later.